I remember the first time I saw a piecewise function, I was like, what? Honestly, it's just learning how to read it. What this question says, or what this function says, is if the x value is less than or equal to 2, you do this to it. If the x value is greater than 2, then you do this to it. So it's kind of like there's two functions in one. But depending on the x value, that decides which function you use, or which rule you use. You're either going to use the x minus 1 rule or the 5x squared rule. Complete the following table for the following function. So there should be a table here, so let me put a table up here. Actually, I should put f of x right here.
What is this?
And so this is called a piecewise function.
Piecewise?
Yeah, just same way that you would spell like Reese's Pieces, like Piesrec. I better just write it.
Piece what function?
Piecewise.
Oh, that's not what I was thinking. I thought you meant like piecewise. Like
Oh man, I hope I spelled that wrong. Is it P-I-E or P-E-I?
No, except after
I before E except after
I before E?
Only
after
C.
Okay, so it just looks weird right there. Okay, so let's say you got numbers like this, 0, 1, 2, 3, 4, and 5. Okay, which one would I plug the 0 into? Would I plug the 0 into the x plus 1, or would I plug the 0 into the 5x squared?
X minus 1.
And you know by deciding which one would be true. Which condition does it follow?
It's lesser
It
than.
definitely follows this one right here. So that means you use this rule. So that means you're going to go 0 minus 1, and your result is negative 1. So you put negative 1 right here. When you check 1 follows the same one. It satisfies this condition, so you use x minus 1. 1 is less than or equal to 2. So I'm going to write, I'm going to plug in 1 right here. 1 minus 1 is 0, so I put 0. And then the 2, oh, look, there's a 2 right here. What? Okay, the 2, which one is true? The top one. The top one's true, so that means we're going to use this one right here. What is 2 minus 1?
1.
That is 1. Okay, so far so good. Now we have the number 3. Now this is when things are going to change just slightly. If I put a 3 in there, it's not true. If I put a 3 right here, it is true. So that means we're going to use 5x squared. So I just plug in 3 to 5x squared. It's going to be 5. 3 squared. 3 squared is 9 times 5 is 45. So I put 45 right here. And then I plug in a 4. 4 satisfies this condition, so we're going to use 5x squared again. 4 squared is 16. 16 times 5 is 80. So put 80 right there. Last one is going to be 5, and 5 definitely follows what 4 is doing. So you got it. Okay, cool. You already got it. 125. Now this piecewise function has two different rules in it. Sometimes there's more, but it follows the same protocol. You just have to, whatever satisfies this condition, you plug it into that one. Whatever satisfies this condition, you plug into that one.
So how would the answer look? Would it just be the function?
Okay, I wanted to throw this scary thing up for you guys.
I don't want to know.
Because I don't want it to be scary anymore. Things are scary when you've never seen it before. But when you've seen it before, it's not that scary anymore. So this right here is called the difference quotient. Dang it, I made my marker a little fatter, hoping that it would be easier for you guys to see, but I don't know if I like the fatness. When you find a slope in a curve, you're only finding it at a certain point. So I'm going to look at this point right here, where x equals 5. What is the slope at that point? Well, before what you guys would do is you'd pick 2 points, and you find the slope of this by counting the rise and then the run. Now, is that accurate? Whatever this is going to be about, let's see, that's about half right there. So it'll be 1, 2, 3 plus a half, so it's about 3.5. That's about, rough estimate. And then this is a 5. So is my slope about 3.5 over 5?
Yes.
I mean, you wouldn't leave it like that since the decimal. You'd actually divide it out. Is that what my slope is at this point? Is it 3.5 over 5? Or is it something like, should I pick this point right here and draw my line, and is it more like this? Is it more that steep? Is it that steep at that line, at that point? Or is it more like this steep right here? Whoops. It's any of them. Well, do you guys know what a tangent line is?
Yeah.
Now, a tangent line would only touch this point at one point, or only touch this line at one point. Now, it's kind of hard because of the thickness of this line right here. But if the line touches the curve at one point, that's a tangent line. And so if you can just find the slope of that line right there, that tangent line, then you found the slope at that given point. So let's talk about how you find slope. We know what slope is. Slope is rise over run. Now, how do you find the rise when you're given 2 points? Yeah, you just go y2 minus y1, x2 minus x1. Okay, so that's how you would find the slope. Now, I kind of want to write this different. I want to use function notation. So, instead of saying y2, tell me if I can say this. Can I say f of x2? Does that equal y2? Like if I take this x and plug it into the function, will it give me y2? It will, won't it? Like when you take the x value, you plug it into the function, it gives you the y value. And so instead of saying y, we're going to say f of x sub 2. You guys okay with that? I am not okay with that. For the y sub 1, instead of saying y sub 1, we're going to say f of x sub 1. So in order to get this y, we would plug in the x sub 1. On the bottom, we'll just keep it x sub 2 minus x sub 1.
Wait, so on the top, would you just plug in the x's?
So here you have the slope written more with function notation. Now, when we look back at this, what we want is, in order to find a slope, we still need 2 points, but we only have 1 point. So how close of a point do we need to have on this line so that we get 2 points that will give us what the slope is at that given point? Should we pick 4? Is that a close enough point, which is right there? Is that a close? No, that's not a close enough point. Let's pick a closer point. Can we pick 4.5? Is that a close enough point? Oh, can we get closer? Yeah, we can get closer. We can pick. We could pick. What about 4.9? Yeah, that's really close. Wait, what about 4.999? That's even closer, yeah?
What, 4.999?
Yeah, what about 4.9999999? Okay, we can get really, really close. But how close should we get? I don't know. So this is what we do. That's why there's a plus h right here. That h represents the difference between this x and this x. That h, that's what the h represents. Now, what is a difference? How do you find a difference? Can you guys tell me? You subtract, right? So check this out. You can actually say that this equals h, because that's the distance. So we have f of x2 minus f of x1 over h. Oh, that's where that h comes from. The h is the difference between the 2 points that you need in order to find the slope at that given point. So how come this says x plus h and x? How come it doesn't say x sub 2 and x sub 1? Well, because one of these is x sub 1, and the x sub 2 is going to be that x plus the difference. And that gets really confusing. Just like me saying it to you guys right now, that's confusing. You really do have to use it and see it a lot before you start really wrapping your mind around it. But that's why I'm giving it to you guys right now, because in the future, you guys will work on it more. Maybe we'll see things throughout this year that will relate to this, and you'll go, oh, I'm starting to get that. So right now, the thing that you guys need to know, remember I told you I'd tell you that? Right now, the thing you need to know is how to plug this function into the quotient, into the difference quotient. So let me show you guys that. So this is how we plug it in. This says you're going to take the f function, and plug this into it. And you're going to take the f function again, you're going to plug the x into it. This part's really nice. Why? Because the x is already in there. So you don't have to do anything to the second one. It's the first one you have to do stuff with. So for the first one, this one right here, I'm going to do it in blue. You're going to take the function, which is this right here, and you're going to plug in x plus h, square it, and you're going to subtract 4, plug in x plus h again, and then you're going to add 7. The rest of it looks like this. We have minus, we have an h on the bottom right here, and then we have x squared minus 4x plus 7. You guys see where I got this?
Where did you get the +7 from? The blue one.
Hey, some of you guys are like, where'd the blue stuff come from? Check this out. You see this function right here? I'm going to rewrite it without the x's. It's f of something equals something squared minus 4 times something plus 7. And what's the something we're using?
X plus h.
Yes. So we're plugging in x plus h here, x plus h here, and x plus h right here. That's how I got the blue stuff.
How did you know where to split it up?
Okay, let's simplify. So we got to do this one first. And to do that, you have to distribute and FOIL and all that stuff. So you're going to get x squared plus 2xh plus h squared. And then right here, you're going to distribute that negative 4 to get negative 4x minus 4h. Then you have the plus 7. And then we have the rest of this stuff. We have minus x squared. I'm distributing this negative as I do it. Plus 4x minus 7. All over, that's line. All over h. All right, let's simplify stuff. How many x squareds do we have? Well, we have a negative 1, or a positive 1 right there, and a negative 1 right here, so those cancel each other out. The 2xh, there's nobody like him, so I'm just going to write 2xh right here. Do I have anybody like the x or h squared? No, nobody like him. Anybody like? So I'm done with these guys. Anybody like the x term?
Yeah.
Oh yeah, there's a 4x over here. Okay, they cancel each other out because they're opposites. Anybody like this h term? No. Okay, so I have minus 4h. And then what about those 7s? Oh, those 7s also cancel out. So I have all h's on top. I have one h on the bottom. Can I divide each of these terms by h?
Yeah.
Yes, and so now it looks way prettier. It is 2x plus h minus 4. This little expression right here will give you the slope at any given point. So at 5 right here, what's the slope at this point? Well, you would just have to plug it into this. But that's if this function was this, and this function is not this right here. So that's how you do it. And for this class, you really just need to know how to plug it in and simplify. So we're working on the algebra part of it.